Okay, we'll call this section 17.1, part 2. Yesterday we talked about alkanes that were what we call straight chain. All the carbons are attached in a row. Alkanes actually have the ability to have a branch or what we call a substituent attached to the main carbon chain. So alkanes that have 4 or more carbons can have different arrangements of carbon atoms. We call these isomers. They have the same formula, but different arrangements of atoms, different structural formulas, and therefore they have different properties, different boiling points, different melting points, and different names. There are 2 structural isomers of C4H10, butane. So this is normal butane, 1, 2, 3, 4 carbons, straight, all the carbons are in a row. We get this little zigzag going here, and that's 4 carbons, and that's butane. This is 1, 2, 3, 4 carbons, but notice how the middle carbon has something attached to it. So this is 3 carbons with a 4th carbon attached to the side of the main chain. So it has a different structure, and therefore it's a different compound. Alkanes that have 5 carbons have 3 different structural isomers. We can see the 5, 1, 2, 3, 4, 5 carbons in pentane, or we have 4 carbons, 2, 3, 4 carbons with a 5th carbon off to one side, or we can have 3 carbons with a carbon off to each side of the middle carbon. So we've got 3 different ways we can arrange 5 carbons and 12 hydrogens. When naming alkanes that have what we call a substituent, the branch is known as an alkyl group, which is an alkane that is missing 1 hydrogen atom. So instead of CH4 methane, we would get CH3, and that's methyl. So we change the name, we change the A and E ending to YL. So this one is methane and this one is methyl. So the number of carbons is the root word, just like we learned yesterday. They are always attached to a carbon chain. We can also attach halogen atoms to the carbon chain, and they are known as a halo group, and we name those fluoro, chloro, bromo, and iodo. These are some common substituent groups and their formulas and names. So we have the methyl group we just looked at with CH3. We have the ethyl group, which is a CH3 and then a CH2, 2 carbons, 1, 2, and instead of ethane, it's known as ethyl. If we have 1, 2, 3 carbons, then that is known as propyl. If we have 3 carbons and it's attached to the middle carbon, it's known as isopropyl. You may have heard of isopropyl alcohol, and it has this similar structure with an alcohol group attached right here. This point is where it's attached to the main chain. So if it's attached to the main chain of carbons at the end, it's known as propyl. If it's attached at the middle carbon, it's known as isopropyl. We have 4 carbons, 1, 2, 3, 4, known as, instead of butane, it's butyl. And if it's arranged similarly with the 3rd carbon in the middle, it's known as isobutyl. We don't see that one very often. And then, of course, we have the fluoro, chloro, bromo, and iodo substituent groups. So now we're going to use these substituent groups and learn how to write the name for branch chain alkanes. The first thing you want to do is you want to count the longest chain of carbons. So here I have 1, 2, 3, 4, 5, 6. That's my longest main chain. That's what we call a parent chain. I could number it one. I could go 1, 2, 3, 4, 5, 6, but that's still the same length of carbons. So the parent name of this carbon is hexane because it has 6 carbons. Then you come in and you number the carbon atoms from the end nearest to a substituent group. We're going to number the carbons. So I see here I have carbon, this is carbon 1, 2, 3, 4, 5, and 6. We have to give the location of the carbon substituent groups as well as the halo substituent group. So then we name each substituent group and we give the location, the carbon number, as a prefix to the main chain number. We give the substituent groups in alphabetical order and we use numbers to number the location. So for example, this one has a methyl group on carbon number 2, it has a methyl group on carbon number 4, and has a bromo group on carbon number 4 as well. So we say 4-bromo, 2,4-dimethyl, di meaning there's 2 methyl groups, and then hexane. So substituents are listed in alphabetical order. So bromo goes first and then methyl. We use hyphen between numbers and names. And if there's 2 or more same substituent, we use a prefix, di, tri, tetra, so on. And commas separate numbers. So when we talk about alphabetical order, prefixes do not count in alphabetical order, just the name of the substituent group itself. So let's see if we can write the name for these 2 compounds. So first of all, for letter A, let's see if we can find the longest chain of carbons. So I start here, 1, 2, 3, 4, 5, 6, 7. That's heptane. Or I can start up here and I can go 1, 2, 3, 4, 5, 6. That's only 6. So I always want to go with the longest chain. So that is heptane. So I'm going to write heptane as the parent number. Then I'm going to number my carbons. So 1, 2, 3, 4, 5, 6, 7. Doesn't matter which way I number them. If I started on this end and numbered them 1, 2, 3, 4, that substituent group still going to be at carbon number 4. So here we have a substituent group that has 1, 2, 3 carbons. So that is propane, right? But it's not attached to the end carbon, it's attached here to the main chain at the middle carbon. So that makes it isopropane. Propyl, sorry, not propane, isopropyl. Heptane, and we have to say the letter of the number of the carbon where it's attached, and so we put a 4. So the name of this compound is 4-isopropyl heptane. And that's a mouthful, I know. Looking at the next one, we see here, I'm going to start here, carbon 1, 2, 3, 4, 5, 6 is my longest chain. I could count this 1, 2, 3, 4, 5, 6. That's 6. 1, 2, 3, 4. That's only 5. So 6 looks like to be my longest chain. So the parent chain is going to be hexane. Then I number my carbons. You start at this end. I number 1, 2, 3, 4. So my numbers for my substituent groups would be 2 and 4. If I start at this end, I would 1, 2, 3, 4, 5. I'd have 3 and 5 as my numbers. So I want the lowest possible number. So I'm going to start at the left with my numbering. So 1, 2, 3, 4, 5, 6 is my numbers. I see this is a methyl group. This is a methyl group. And this is a methyl group. So there are 3 methyl groups. So we're going to, 3 is tri. So we're going to say there are 3 methyl groups. So we're going to say trimethyl hexane. Now we have to say where the methyl groups are located. So we'll say 2, 4, 4 hyphen trimethylhexane. So that would be the name of this compound. We can work backwards. We can, if given the name, we can come up with the structural formula. So if I'm going to try to draw the structural formula of 2,3-dimethylbutane, you're going to, first thing you want to do is draw the main chain or the parent chain. So here I see butane is my parent chain. So I've got 4 carbons, 1, 2, 3, 4. If you want to do the line angle formula, I see 1, 2, 3, 4 carbons right there. And then we number the chain and then place the substituent groups on it. And so then we number the chain 1, 2, 3, 4, and it was 2 methyl groups, 1 on carbon number 2, so I write the methyl group there, 1 on carbon number 3, and I put the methyl group here. So in the line angle formula, I draw one line going up for one methyl group, and I draw this other line going down on carbon 3 for the second methyl group. In the condensed structural formula, then you add in the hydrogen atoms so that every carbon gets its 4 bonds. So here at the bottom, I see I put a CH3 on the end carb, both of the end. And then I put a CH here and here on the 2 middle carbons because they already have 3 bonds, so they only need 1 more hydrogen. So let's see if we can write the structural formula and line angle formulas for these, starting with the parent chain pentane. So the parent chain pentane means I have 5 carbons, 1, 2, 3, 4, 5. And if I'm going to do the line angle formula, I'll do 1, 2, 3, 4, 5. So that will be the line angle formula. Then it says that I'm going to number my carbons. 1, 2, 3, 4, 5. And you don't have to write the numbers, but sometimes it helps. And then on carbon number 2, I'm going to put a bromo. And on carbon number 4, I'm going to put a methyl. So on carbon number 2, I put a bromo. And on carbon number 4, that would just one line indicates a methyl group. Then I'm going to come in and add my hydrogens. So I need 3 on this one. This one already has 3 bonds, so I'm going to put a 1 there. The third carbon only has 2 hydrogens, 2 bonds, so it needs 2 hydrogens, 1 hydrogen, and 3 hydrogens. So that would be kind of sloppy, but 2-bromo-4-methylpentane. Then the second one there, propane is 4 carbons. No, sorry, propane is 3 carbons. 1, 2, 3 carbons. And the second carbon has both a chloro group and a methyl group. So that's the 2 substituent groups. If I did the line angle formula, I would see a chloro group and then another substituent group there, the methyl in the middle. I just need to add my hydrogens on the end. The middle carbon doesn't get any hydrogens because it already has its 4 bonds. So these last few slides are about some uses and properties of alkanes. The first 4 alkanes, methane, ethane, propane, and butane, they're gases at room temperature and are used as heating fuel. Alkanes with 5 to 8 carbon atoms are liquid at room temperature. They are highly volatile, which means they're very flammable, and they are used in fuels like gasoline. Gasoline is actually a mixture of several different alkanes. Higher numbers of carbon atoms have higher boiling points and are found in other fuels like kerosene, diesel fuel, and jet fuel. We have motor oil, which is high molecular weight hydrocarbons used to lubricate engines, of course. Mineral oil, mixture of liquid hydrocarbons used as a lubricant, also can be taken as a laxative. Don't recommend taking a lot of it. Alkanes with 18 or more carbon atoms are waxy solids at room temperature. They're known as paraffins, and they are used in the waxy coatings added to fruits and sometimes vegetables to help retain moisture and enhance their overall appearance. Vaseline is a semi-solid mixture of hydrocarbons which has more than 25 carbon atoms, used in ointments, cosmetics, and as lubricants. Here's an example of paraffin use with 18 or more hydrocarbons. The waxy coating on apples makes them shiny. Is a paraffin wax. The main type of reaction that alkanes undergo is combustion. So if you'll recall from last year, combustion reactions are hydrocarbon compounds combining with oxygen, burning to release carbon dioxide and water, and then energy, of course. So here's a propane tank undergoing combustion right here, soldering this copper pipe. But remember, oxygen is a reactant, carbon dioxide and water are the only 2 products. Talking about a little bit about solubility and density of alkanes. Crude oil is a mixture of lots of different kinds of alkanes. The alkanes in the oil don't mix with water, and they are less dense than water, so they form a thin layer on the surface, spreading over a very large area. You might remember in April of 2010, the explosion on the oil drilling rig in the Gulf of Mexico caused the largest oil spill in U.S. history.